Yeah. So tell me, based on last class, you can answer these questions. So tell me combination reaction. So where do we have combination reaction? See, option combination reaction is nothing but here it is combined, right now? Yeah. Next, decomposition means, see here, see KClO3 undergoing decomposition. Next, disproportionation reaction, same species undergoing reduction, oxidation. So, and next displacement. See, they are asking just given list is there, identify just disproportionation reaction. Okay, right. And next, displacement reaction, AgNO3. So Cl is displacing nitrate. Okay, that's it. So based on that you can answer this, right. Next question here. So tell me, which are the following reaction is not an example of disproportionation reaction? So here we have -2 oxidation state, I mean that is for peroxide ion. So -1 converting into -2 and 0. So I can say this species is undergoing reduction and oxidation. So this is disproportionation reaction. They are asking not. Okay. So now tell me here +4 converting into +5 and +3. So this is also disproportionation. Next, what about this? Here +7 converting into +4. Okay, right. And yeah, tell me.
Oxygen, I guess. Oxygen should be.
Oxygen already -2 here. This side also reacting with metal means -2 only. Here also -2. So this is not a disproportionation reaction. So we can take option 3 and you can check for fourth one. See here, like manganese here is in +6 oxidation state. Converting into permanganate +7 and manganese dioxide +4. So this is also undergoing disproportionation. So most suitable answer is 3. Easy only this one also, right. Next. This we'll do today, this concept. Titration questions, I mean law of equivalence concepts. So tell me, based on the previous class, you can answer this question also fast. So what is your answer? Just balance the equation.
2Mn2 5C2O4.
Just ignore that whatever the coefficients they have given. Write the equation.
16C answer is.
MnO4 minus plus C2O4 2 minus plus H plus Mn plus 2 plus CO2 plus H2. So do not look back into your books again. Anyways, we practiced PYQs that day also. But tell me for this one without looking back. See, manganese +7 converting into +2. And here +3 converting into +4. So now how many electrons?
2.
Here 5.
5 into 2.
And this one is 2. So now what to do? Equalize this electron. Simple, multiply this number here and this number here. So in order to make equalizing the electrons, 2MnO4, 5C2O4 minus 2, H plus as it is, 5. See, manganese is multiplied with 2. So reduction equation multiplied with 2, oxidation equation with 5. Okay. So it means 5 2s are 10. See, 2 carbons are there. Multiplying with 5 2s are 10 carbon dioxides I can write, and plus H2. Okay. After doing this, now look, manganese balanced, carbon balanced. Next, oxygens you check, 8 plus 5 4s are 20. 28 are there this side, and that side we have 20. So 20 only means we can add 8 H2O so that it becomes 28 oxygens. Now how many H plus? 8, 16. So 16 H plus. So they are asking what is the value of C. It means 16 it is. Number of H plus ions. Simple only, right. Next one. Will you try this question? Fast, fast.
What is the 2ACR
That's what. Ignore these coefficients. Just take the equation and balance it first. After that, you can verify, like substituting that ABC values, you will get. Huh?
You have to take 2.
Just take equation only. Ignore that ABC, like those things. Ignore that also. Okay, first identify the oxidation states. Plus 6 here. 2 3s are 6 means plus 4 here. And plus 3 plus 6 here. Okay, after that chromium converting from plus 6 to plus 3, 2 3s are 6. So 6 electrons here, and this case plus 6 is converting into plus 4 is converting into plus 6. It means 2 electrons.
Yeah. Cross multiply.
So now what is a suitable integer to multiply the equations in order to make same number of electrons?
You can multiply, so 3 into
So I can make this equation multiplied with 3 so that it will become 6 electrons, and this is keep as it is. Okay, so that will get Cr2O7 2 minus plus SO3 2 minus. I am multiplying equation SO3 equation with
3.
SO3 equation with 3. So here 3 and here 3. After this, just look at the chromiums. Are they balanced? No. So just multiply 2 here so that it will become balanced. Next, sulfurs are 3 here. This side also 3. Next, oxygens are 3 3 is a 9
16.
plus 7. So 16 oxygens this side, and product side
4.
12 oxygens are there. So 4 more are required. So written 4 H2O. Now how many H plus ions? So 8 H plus. That's it. Now look at these coefficients A, B, C's.
A is 1.
What is our A? A is 1. A is 1 here. 1 and
B
B?
is 3.
B here 3. Okay. B is 3. Yes. And C? C by 2 is equals to 4 we got. So C will be 4 2s are 8. Is this clear? See, just ignore that coefficients terms like whatever they are saying. Take the normal equation, just unbalanced equation, balance it. After getting your answer, relate them with that. C by 2 is nothing but equals to 4. C will be 8. So 8. So your 1, 3, 8, fourth option will be very perfect answer for this question. Is this clear or not? Right. Next. This question also we will do today. This is done now.
6 option 2 answer.
Okay, next. Okay, we'll do. Okay, so now we will be discussing about equivalent weight. What is that? So that we can use the concept of law of equivalence after that. Concept of equivalence we will be discussing here. See, when I am reacting something like N2, I am writing this equation N2 plus 3H2 gives rise to NH3 I am writing. First of all, balance this equation. That's it. Okay, so what do we mean by equivalent weight? So equivalent weight means equivalent weight is that weight which reacts with 1 gram of hydrogen, 1 gram of hydrogen or 8 grams of oxygen, like this. So what is this? See, first of all you have written this equation. Now 1 N2 means how many grams it is? 28 grams. Right now N2. Next this one 3 2s are 6 grams, and this is 2 into 17 34 grams. Now what is the equivalent weight means? I told you
1 gram amount of.
Yeah, Abdul Rahman, good evening. Yes. So equivalent weight is that weight which react with 1 gram of hydrogen. So as per the equation, 6 grams is reacting with
28.
Huh.
So, 1
So
liter
now,
is 4 grams.
in order to make this 1 gram, so this will become 28 by
4.
6.
Sorry, 6.
So that it will be 17 by 3. So now what is the equivalent weight of nitrogen, I can say?
17 by
17 by 3, because this is the weight, this is a packet of weight that is reacting with 1 gram of hydrogen. So what is the equivalent weight of nitrogen, I can say?
17 by 3.
17 by 3. Similarly, can you tell me what is the equivalent weight of ammonia?
60, 30.
So 6 grams forming 34. So 1 gram will form 34 by 6. That's it, 17 by 3. So here this is not 17 by 3, bro. 14 by
3.
14 by 3. So 14 by 3 is the equivalent weight of N2 and 17 by 3 is the equivalent weight of ammonia. Like this we need to answer. Is this clear or not? This is as per the equation. So now again I am giving the definition of equivalent weight. Equivalent weight is that weight which react with 1 gram of hydrogen or 8 grams of oxygen. Okay. So why we are writing 1 gram of hydrogen or 8 grams of oxygen? Because see, 2 grams, for example, in order to form this water molecule, see, half mole is reacting with 1 mole right now. So half mole means what is the weight? 16 grams right now. So for 1 gram how much it will be? Just divide by 2. So 8 grams. See, I can say, instead of saying 1 gram of hydrogen, or I can also say 8 grams of oxygen, because they are having same equivalence. Is this clear or not? Or I can also give the definition with respect to halogens, like chlorine I can say. Equivalent weight is that weight which react with 1 gram of hydrogen or 35.5 grams of chlorine. Or at STP condition, see, we know hydrogen means, what is the weight of this hydrogen? 1 mole of hydrogen means 2 grams right now. So 2 grams at STP occupies 1 mole of hydrogen, 22.4 liter at STP. So now instead of saying 2 grams, equivalent weight is that weight which react with 1 gram. So it is 2 grams. It means in order to make it 1 gram, just divide by 2. So that is 11.2 liter at STP. So now I can also define equivalent weight is that weight which displaces 11.2 liter of hydrogen at STP or 5.6 liter of oxygen at STP. Also I can say chlorine. Also we can like that we can relate. Okay, right. Now when it comes to normal reaction, normal atoms, for example I have any element A I have. So during the reaction it is, for example 1 mole of A is there. So during the chemical reaction or during the process it is losing 2 electrons, I mean 2 moles of electrons from 1 mole, or 1 atom is losing 2 electrons. So now what is the equivalent weight of this particular atom A here? So equivalent weight will be taken as, what is the weight of that atom? It can say atomic weight divided by how many electrons it lost? 2. So take it as 2 here. If it is losing 3? 3. So this, whatever the electrons involved in this process, call its valency factor. What is that? Valency factor or N factor. Okay. So now, for example, when aluminium combining with oxygen, so it will form Al2O3. Now tell me what is the N factor of aluminium here? +3. 0 is converting into +3. So its N factor is 3. Okay. If magnesium combines with anything, that will form, generally it will form Mg+2 ions. So what is the N factor it has? 2, like that. So all alkali metals will be having, when it combines with something, forms +1. So its equivalent weight equals to atomic weight. When it comes to alkaline earth metals,
by 2.
its molecular weight, atomic weight by 2. Okay. And for 13th group elements like aluminium by 3 you got. Okay, like this. Okay, for example, nitrogen atom is there, okay, so it is in like N2 form. Now it is converting into NH3 minus. What is its N factor, tell me? See, what is the N factor, what is the oxidation state here? Minus 3. Here it is 0. So 0 is converting into minus 3. How many are there? 2. 2 nitrogen atoms, each one converting from 0 to minus 3, it means 3. So total change is 6. So total N factor will be,
Balance the equation like sir 2NH3.
huh. So total N factor will be how much?
6.
So it means equivalent weight of N2 in this reaction will be how much? Its atomic weight, like molecular weight,
28
by 6. It means 28 by 6. So like equivalent weight will be varies depending upon type of reaction it is undergoing. So in this particular reaction you have seen that 2 nitrogen atoms converting into minus 3. In some other reaction it will be converting into minus 1, minus 2 or 0, or depending upon the condition, or plus 1, plus 3, like that.
So what if it has converted into 0?
No change, you can say. Okay, so that is how you can find its N factor. Is this clear or not? Right. Next, here when it comes to acids like HCl, now how many H plus ions it is releasing? Call its
N factor.
N factor. Similarly, if it is a base,
OH minus.
so for example KOH I am taking, how many OH minus ions it is releasing? That is called its
N factor.
N factor. So now
Salt.
for sulfuric acid you tell me
2.
how many H plus ions it can release? 2. Okay. Now similarly, if I give you anything like salts, let us generalize this.
Their-
Salts.
Their balance.
See, for example, I have some salt like
NaHSO4.
Na2SO4 I am taking. Now how many cations it is releasing from here?
1.
See, how many cationic parts are there? 2 sodium ions are there, or 1 sulfate ion we have right now. So what is the total positive charge you are seeing? 2. See, 2 into each one with plus 1 charge. So total charge is plus 2. Or what is the total negative charge you are seeing? Minus 2. It means for in the case of salts, N factor will be considered as whatever the total positive charge or total negative charge is its N factor. There is no sign for N factor. Don't put as minus or plus.
So you can say number of electrons divided by 2, like the number of electrons involved in the bond by 2.
Not by 2, just number of electrons involved.
They are sharing.
I covalent bond.
Okay. Similarly, see, even for acids also you can consider like that. See, how many cations will be coming from this?
2.
That's it. That will be its N factor. Even for bases also, how many cations it is releasing? 1. That's it. It's its N factor. Our OH minus is nothing but number of negative ions only, no? Okay. So for example, I have a salt of AXBY type. Here AXBY nothing but X represents number of cations, Y represents number of anions. So how it will be written? If it is undergoing dissociation, consider it as a salt.
A power by
So X time, how many A's are there in this?
by
How many A's are there? X number of A's. So XA to the power Y
dot sorry,
plus and Y times B with charge minus X. So what is the total negative charge you are seeing or total positive charge you are seeing?
y
See,
into minus x.
number of cations are X multiplied with what is its charge for each? Y. So this will be the N factor of this particular salt. Similarly, if I ask for this, Y are there, Y, B anions are there, and each one is having charge X. So both are same only, X into Y, Y into X, 2 into 3, 2 into 3, like that, right? So now, what is the use of studying this? Because we are going to do now redox reactions, right? I mean titration of redox reactions, acid-base reactions. So there we will be using this equivalence. See, before going to that, you know normality. What is normality means?
Weight by number.
Gram equivalent numbers, number of gram equivalents by
Total weight. Sorry,
volume of solution in liters. Okay, so what is this gram equivalent number means?
Number
This
of
is
moles by
number of moles into its N factor. So we can write this in liters. Okay, so now N by V means what? Again we can also write molarity into N factor also, like this also we can take.
We can write
Okay, or if I want,
given weight by atomic weight into n factor by V.
so number of gram equivalents means I can also write N into V, normality into valency factor from here, right now. So now when redox reactions are taking place, or acid base titration or acid base reactions are taking place, or precipitation reactions are taking place, they follow law of equivalence. What they follow?
Law of equivalence.
Equivalence. It means equivalence of reducing agent will be equals to equivalence of oxidizing agent, because in every redox reaction there will be oxidizing agent, reducing agent. For example, I am writing a question. Look, number of moles of KMnO4 required to oxidize 1 mole of oxalate ion in acidic medium. Not required, acidic medium, like this they will give. Okay, simple question. So first of all, you no need of balance in the equation, nothing, just look at here. KMnO4 is written, and what other thing given? Oxalate ion is given. Okay, so we know, remember KMnO4 is there now. If I take acidic medium, already I explained, whatever may be the reaction, no need of balancing here. KMnO4 in acidic medium, +7 oxidation converts into +2 in acidic medium. In neutral medium, manganese +7 converting into, this is neutral or slightly basic, okay, slightly alkaline, converts into +4. If it is strong alkaline, strongly basic,
+6.
alkaline, converts into +6. So what is mentioned here? Acidic medium. So for oxalic acids, generally if they won't mention acidic, basic or neutral medium, just consider acidic medium, because oxalic acid itself is a acid. Okay, like that. Okay, so now we know +7, now it will be converts into
+6.
acidic medium now +2. Okay, so then next here +3. See, if KMnO4 is undergoing reduction means, this is undergoing reduction means definitely carbon from oxalate should undergo oxidation, because it is a redox reaction. So what is a possible oxidation state for carbon? +4 in an oxidation manner. Okay, so converting from +3 to +4. I am not balancing the equation, right? So what is the other thing here we can make here? This species undergoing reduction and oxidizing others. So I should call this KMnO4 as a, see, it is undergoing reduction, oxidizing others. Oxidizing others means this is a oxidizing agent. So I can write oxidizing agent. What about this? It is undergoing oxidation and reduces others. So reducing agent. So you can write equivalence of oxidizing agent equals to equivalence of reducing agent. So how many equivalents we can write? See, here the given number of moles of KMnO4 and oxidizing 1 mole of oxalate ion. So it means simply you can take N into N factor of oxidizing agent equals to N into N factor of reducing agent. So what is our reducing agent here?
Oxalate ion.
Oxalate ion. How many moles given? 1 mole. So take here 1 mole. What is its N factor? +3 is converting into +4. How many carbons are there? 2. Into each carbon converting from +3 to +4. It means 1. So total N factor is 2. See, always take from your starting material how many atoms are involving in that process. You should multiply with that number. So 2 into each one is converting from +3 to +4 means change will be 1. So 2 into 1, that is 2. Here +7, how many manganese ions are there? 1. +7 converting into +2, it means total change is 5. So like this. Okay. Now you got Number of moles of oxalate ions are 1, and what is its N factor you got? 2. And this side, number of moles of KMnO4 you need to find, and how much its N factor? 5. So that's it. So now total number of KMnO4s required for this process is what? 2 by 5. That's it.
0.4 moles.
0.4 moles of KMnO4 is required to oxidize 1 mole of oxalate ions. Like this you need to practice or solve the questions. Okay. Now look at this question. Yes, tell me this one. Just now we did titration of KMnO4 and oxalic acid in acidic medium, change in oxidation number of carbon at the end point.
1 plus 2.
Change in oxidation number.
Plus 2.
Change in oxidation number of carbon at the end point. Change in oxidation number is how much? Oxalate ion plus 3 is converting into plus 4.
2.
They are not asking N factor. What they are asking? Read the question consciously. Plus 4. Okay, plus 3 is converting into plus 4. So your answer should be plus 4. Okay, now can you try this question? Tell me. 15 ml of aqueous solution of Fe plus 2 ions in acidic medium completely reacted with 20 ml of 0.03 aqueous dichromate ions. The molarity of Fe plus 2 ion is. Fast, tell me. Let's do. So 15 ml of aqueous solution of Fe plus 2 ions. Fe plus 2 ions in acidic medium completely reacted with dichromate Cr2O7 2 minus ions. So here plus 6, chromium already in plus 6. Now it will be converts into plus 3. It means this is undergoing reduction. So I can say this is an oxidizing agent. Okay, what is its N factor? Plus 6 converting into plus 3 means 3. And how many chromiums are there? 2. Total N factor change is 6.
Sir, how do you know it will convert into plus 3 only?
So you need to, like, you can remember that chromium in acidic medium converts into plus 3, like whatever I have given, manganese acidic medium plus 2, plus 4, plus 6, like that. Okay, next here iron is there now, that will be converting into plus 3. Okay, it means this is undergoing reduction, means other will undergo oxidation. So here it is undergoing oxidation, so I can say this is a reducing agent. So how many N factor here? What is the N factor here? 1 iron. See what I am doing, I am not balancing the equation, just giving you the simplest way to calculation. That is what the use of law of equivalence. I am not balancing the equation, just giving you the general idea. So plus 2 is converting into plus 3. So it means 1 N factor will be 1 into 1 only, no? So N factor change is 1 only. So the next what you can do?
N factor.
Equivalence of reducing agent equals to equivalence of this oxidizing agent. So what they have given in the question, they have given 15 ml of Fe plus 2 ions completely reacting with 20 ml of 0.3 molar chromate, dichromate. So it means molarity is given, but what we need to take here? Normality. N into V of oxidizing agent, N into V of this reducing agent. Next, what is N here? How can we relate normality and molarity? What is the molarity given? 0.03 into its N factor is how much for oxidizing agent? 6.
Into?
How much volume? 20.
Into that.
This side for reducing agent iron they have given 15 ml they have given, and what is its N factor we got? 1 we got, and now we need to calculate its molarity. That's it. So M we need to find. So next
5 1s are 5 4s are 5 3s are.
So this is 3s are, this is 4s are. Next
3 1s are 3 2s are.
0.01 This will be, so molarity will be how much? 24 into 10 power minus 2. So what is our answer in this bracket? Here
24, we got 25.
should be 24. Okay, is this clear or not? See, basic, that small mistakes, how you are doing it? Show me.
M1 equals to
Don't take M1 V1. Always use equivalence, means N1 V1 you should use. Okay, normality should be taken. Then you take relation between normality and molarity in the next step.
like divided by n factor.
Normality equals to molarity into n factor, that you should take. Normality,
So molarity equals to n by n factor.
huh. Next. Tell me this reaction disproportionation, did we done with this?
No.
Tell me, answer it first.
A is disproportionate reaction.
Hmm.
A is disproportionate and
First one is disproportionation. Which are the following reactions are disproportionation? Means here plus 6 converting into plus 7 and plus 4. This is also disproportionation. Next, plus 7 converting into plus 6 and plus 4. This is not a disproportionation. Next,
not a disproportionate.
next this one. Plus 7 converting into some other species. Plus 7 plus, no, this is not a disproportionation. So AB.
A and B.
Where do we have AB?
Option one.
That's it. Next.
So if something is in maximum oxidation state, then
That,
will not
that won't undergo disproportionation reaction. We know that statement. Using that we can solve that previous question. Tell me answer for this question. 25 ml of given HCl solution requires 30 ml of 0.1 molar sodium carbonate. What is the volume of HCl solution required to titrate 30 ml of 0.2 molar aqueous solution? Tell me.
So NaCO3.
See, this is very simple. Read the question once again. The given data of 25 ml of HCl, they are saying this HCl is utilized for neutralization of 30 ml of 0.1 molar sodium carbonate. Okay, it means first they have did it for, they have taken HCl plus Na2CO3. This titration they have did. So from using this they have calculated molarity of HCl they found. Okay, so after that they used the same HCl having some molarity that we got from this titration for second titration with NaOH having this volume and this much concentration. Now for the NaOH, the second titration using HCl, how much volume of HCl is required for titration with NaOH? That is what they are asking. So take the first step and tell me.
M into n factor.
N into n factor of HCl, that is 25 into
1.
molarity is not given, na? That is what you need to find. Okay, is equals to, what is the volume of Na2CO3 given? 30 into
0.1.
0.1, that's it. That will give you molarity of HCl.
3 by 25.
See, simple man. So 25 NV of N into V of HCl equals to N into V of Na2CO3. Now, what is the N factor of Na2CO3? See, what is the total
Plus
positive
2.
charge and
Sorry,
negative
N
charge?
factor is
2. So take here 2, and what is its molarity given? So 0.1 given molarity and volume given 30. Okay, after taking this side, what is the normality or molarity, that is we need to find for HCl, and volume given is 25. So from this you tell me.
15, 25 by 15.
So 6 by 25 you will get. 0.1 into 30. 3 into 6, you got normality of HCl you got. Next what to do? Same, this normality is used for titration with NaOH.
So
It
we should
means
calculate M.
30 into 0.2 of NaOH will be equals to 6 by 25 into V. So you need to find this V value here.
And also
From-
factor.
N factor for NaOH is 1 only, na? How many OH minus ions it is releasing? Like that. See, simple here, 3 2s are 6 here, 6 and this side also 6 is removed. So volume will be 25.
1 by 0.4, which is 25.
0.1 into 2 3s are.
Second step, first step. Second step.
Don't simplify that. Take it as 6 by 25 only. See, you are taking here 6 by 25 into V equals to 30 into 0.2. It means this side also 6, 6 cancel. So V will be 25. Okay, right. Okay. Next, tell me for this.
50 ml of 0.5 m oxalic acid is used to neutralize 25 ml of sodium hydroxide solution. The amount of NaOH is 50 ml of the given sodium hydroxide solution. Sir, NaOH and sodium hydroxide.
See, wait. 50 ml of 0.5 molar oxalic acid is needed to neutralize 25 ml of sodium hydroxide. Okay? The amount of NaOH in 50 ml. See, first of all, you find it for 25 ml. What is its concentration you will get? So after doing that, we have molarity formula now. What is formula of molarity? Molarity N by V. So M we got. So from this N, you can find weight by
Given weight into 1 by
V. If it is in ml, they have given 50 ml means 1000 you take here. That's it. So from this you can find this. That's it. Okay. Next. Write a question, otherwise I will tell you. Write a question. This is done. Number of moles of KMnO4, number of moles of KMnO4 required to neutralize 1 mole of ferrous oxalate. 1 mole of ferrous oxalate. What is ferrous oxalate formula? FeC2O4.
minus
No, ferrous oxalate. See, do I am saying anything like ions? No, it means it's a neutral molecule.
Okay. The number of moles of KMnO4 required to neutralize 1 mole of
Ferrous oxalate. Okay, this is one more little important model question. Yes, tell me. This is the last question of the session. Manganese plus 7.
Plus 6 to C power 0 and M power plus 7 to plus 6 to 0 to 12.
Got the answer? Okay, first of all write basic what happens here, basic equation. Like Mn plus 7 definitely converts into plus 2. Okay, it means what is the n factor here? 5. Okay, now if you look what happens here, KMnO4 is undergoing reduction, means it is acting as a oxidizing agent. It means oxidizes the other one. See, iron plus 2 will be converts into plus 3. So it is undergoing oxidation, and carbon also here converting from plus 3 to plus 4 means this is also undergoing oxidation. So two species are undergoing oxidation and this KMnO4 undergoing. Yes, you need to take n factor of both oxidation processes. So in this process n factor is 1, in this process also n factor 2 into 1, so 2. So total n factor in oxidation you should take. N1 plus N2 you can take, like N1 plus N2. So 1 plus 2, 3 you can take. This is the important primary step you need to consider. Okay. So now tell me, n into n factor of KMnO4 equals to n into n factor of this reducing agent. Okay. How many? What is the question I given? Number of moles of
KMnO4.
it means n KMnO4 is required here.
So
multiplied with 5, and number of moles of ferrous oxalate given is 1, its n factor is 3. So number of moles of KMnO4 will be 3 by 5. That will be your answer,
which is
0.6 moles. Is this clear or not? Right. So now you can try questions from your module after going home. If you have any questions, we'll discuss in the next class. Okay. So